In this lesson, we're going to be creating this sort of cool particle dancing effect, and we're going to make it so that it loops seamlessly in the end. So we'll do a little bit of particle post-processing. We're going to be working with attributes, getting them in to our pop system, and just sort of fine-tuning all the settings so that we can get a look that we really like. Then I'm also going to do kind of like a little, we're going to do some applied chops where we take... we're going to take a camera rig, and then we're going to basically, we're going to constrain the camera so that it's looking in the general vicinity of the particle system as it's moving around, but it's not going to be like rigidly tied to it. It's going to kind of have some lag and drift, and I think it's kind of a nice, cool exercise in what kind of cool things you can achieve procedurally with chops. And it's going to be cool. We're going to set very few keyframes in this project, which love it or hate it. One of the cool things about proceduralism is that you can get away with kind of a lot without having to do too much animation if you don't want to. All that being said, let's just get this thing started and dive into Houdini, and we'll figure out how we can make this thing. All right, so the first thing I'm going to do is switch over to the quad layout, which we created in the introduction section to this lesson. Then I'm going to do the usual thing, hit the D key, go to the background tab, turn the background to dark, and then under guides, turn off the origin gnomon. And cool. So if you don't have this quad layout, there was a lesson that covered it, but I just want to have my geometry spreadsheet up, and basically I've got this split view over here, but feel free to follow along however you like. So let's create our particle system. I need to create first an emitter. So I'm going to throw it on a sphere. So I'll jump inside the sphere, and I'm just going to scatter some points. So we'll say scatter, and like so. The points appear. I actually want to scatter, they're scattered about the surface. I want to scatter on the inside, so I'll throw it on an ISO offset. ISO offset's just a quick way to make a volume out of your sphere, so you get this nice fog, like so. And then when you scatter your points, they're scattered throughout. I'm just going to increase the number of points to 100,000, and it's asking me to save. I'm just going to increase the points to 100,000. And it's scattering and relaxing the points. You can see that we get sort of this voxelization that occurs, this stepping pattern around the edge. It's just because the volume's pretty low res. I don't really want any relaxation on, so I'm just going to turn this off. It should make things go a little bit faster, but yeah, you can see that voxelization there. I'm just going to go up to the ISO office and crank the uniform sampling divisions up to 50, and there we go. We got a nice kind of even spherical distribution. Next thing I'm going to do is I'm going to add some attribute randomize. So throw down an attribute randomize. I just want to randomize the scale of my points. Now, in order to visualize this, I just want to see right now it's doing it's randomizing color. I want to put down a copy to points, and I'm just going to copy a sphere. Let's throw in another sphere here. I'm just going to copy the sphere onto these points, but before I do that, I'm going to hit pack an instance just so that I can visualize how many or the sizes of my points. I could do this also using a sprite, like so. I find that the sprite sometimes is a little bit, it acts a little weird for me. So I'll try this first, but I'm just going to go back to, oops. Just hitting escape here. I'm going to go back to the attribute randomize and change it to, I want to change this attribute to P scale, and it's a one-dimensional attribute. And then I will go under options, and I will choose, or not under distribution, I'll choose let's do a ramp, and I'll fit the value of 0 we'll fit this to 0.01 and fit the value of 1 to 0.05, something like that. And then I'll just kind of, I'll show you what this ramp does in a second. So let's see if our sprites are working. Yeah, if I plug in the sprites, you can see I get these little smoke puffs. I could also go up here and choose if I hit the file picker here, I'll go and choose under, I'll just go to this Houdini pick Houdini HFS/Houdini/pick, and texture gives me a texture folder. If I hop up, I get a bunch of other pictures I can choose from. I want to choose my sphere deep pick, and sometimes this doesn't update right away. So maybe if I disconnect this and then reconnect it, yeah, sometimes it just takes a little bit to for it to start working. Maybe if I change the sizes, no, that doesn't work. So this is why a lot of times I'll just revert to using the copy to points. So making sure that pack and instance is on, because this is a lot of points and it can be a little bit heavy. I'm going to just maybe change my sphere into I'm going to use instead of a primitive sphere, I'm going to use a polygon, and I'm going to keep it pretty low frequency, just like that. So now I'm just going to wire these two together like so. And I get I can see my my points there represented as these little as these spheres like so. Now if I increase the frequency of it, it should behave okay. It should perform fine. So yeah, now I can kind of get a view of what these different particle sizes are. So now if I go back to the attribute randomize, I could just say, you know, because it's randomly distributing points of scale between 0.01 and 0.05, we get some small points, we get some larger some larger spheres, and we get sort of everything in between, some medium-sized ones over here and here. So now I can just I can actually make it so that this distribution isn't so even. So what I want to have is a couple big particles and then a lot of really tiny ones. So the way I can do that is I can kind of skew this or add contrast to this attribute. And this is really kind of like what you would imagine a color curve controller doing, but it's actually controlling the scale of our particles. So maybe I'll bring this notch down to something like let's bring it down to maybe something like 0.15. And I'll actually just back out so I can see it. I'm kind of liking this distribution. We've got, you know, just a handful of big ones and then a lot of really tiny ones. Now if I crank this even further to the right, you can see that it's essentially decreasing the number of very, very large, relatively large particles. I think like something like this suits me for now, so we'll just go with that. So what I want to do next is I want to add a attribute noise to add some color. So I'm just going to throw this down here and I'm going to wire this in like so. And you can see it's generating a color noise. That's cool. I actually want this to be a one-dimensional noise, but you can see when I do that, it doesn't really work. So if I wire this in here like so, and then highlight our copy to points, it's kind of doing it. We get this, we get a red value. So basically, because color is a color or a vector, it's making a one-dimensional attribute. It's just working with the red value. I actually want to initialize to a grayscale value just because it's easier for me to wrap my head around and it's less distracting. So I'm going to actually initialize color to black. And since this is an additive operation, if I initialize the three-dimensional color attribute or three-dimensional vector attribute and then start doing a one-dimensional noise on it, it should give me a grayscale value. So I'm just going to throw it on a color so, and wire that in here, and it's by default set to white. I'm going to set it to black, and now you can see that it's adding that noise. It's not quite so obvious, so I'm going to just crank this up a little bit. I'm going to say remap the noise. Now you can really see that we got some black pockets and some little bright hot white areas, and I'm going to just maybe I'll just bring the black level up a little bit, since we want to fit our values kind of between 0 and 1 like so. So if I sort my my color value, you can see I've got some that are close to 0.99, which is close to 1, and then I've got others that are in the negative 0.62 range like so. So I want to actually bring this up. I want to have some hit pure black, so I'm going to give it a very small negative number like 0.05, and then I want some to hit pure white, so I'm going to give it just a little bit higher than a number that's a little bit greater than 1, so 1.05. So now our range is going from 1.04 to negative 0.04, so that's good. And then I'll just come down here to the bottom where I have a post processor, and I'll just clamp that off. So now there's a minimum. After all of this is calculated, it will make sure that the minimum is 0 and the maximum is 1. So I've got a bunch of 0 values in my color, and then I've got everything in between that and a bunch of ones. So perfect. Then I think what I'll do here is just increase the frequency so I get a little bit more randomness in my color. So I'm going to go back up here to element size. And to actually increase the frequency, I need to decrease the size of it. So now we're starting to get a bunch of different grayscale values. Cool. And then just so I don't want my actual... I don't want my sim to start off as a perfect sphere. I kind of want it to have a little bit more interesting of a shape. I'll just throw down another attribute noise. And I'll use this one to randomize the position of the points. So it's set to doing color again by default. I'm just going to set this to P. And I'll just increase the amplitude. I want to center the noise so that it isn't moving. If I increase this amplitude, see it's going off to one side. It's because it's adding just positive values. I want to center that noise so it's adding both positive. It's stretching it in both the positive and negative range. So I'm going to do something like that. Maybe we'll do like some value around here. 4.7 seems to work fine. And then let's do just maybe increase the element size a little bit so I can start to see more, you know, kind of like these wispies. I'll do something like 1.3 there. And I'll just call that good. I'm just going to offset this a little bit just to see if I can find any cool other patterns that I like. Maybe something like, let's look at it from a different angle. I actually want to view this down the x-axis because I'll be doing some stuff later on to view it down the x-axis. So maybe I'll pick a good shape from this perspective. And something like that looks pretty cool. So we'll just go with that. Value of 12.53 of an offset. So cool. So I just need to create a null here just so I can reference this easily and keep things clean. I'll call this points, and it's going to look like this. But this is really only for reference. So this is what I want the initialization of my simulation to look like. So we're gonna now just hop into an AutoDOP network and use these points to create our sim for us. So over here in the object level, you know, either jump over to this view or you could hop up here and do it. But since I have two, I'll just do that. So over here, I'm just gonna create a DOPNet. And now in this example, we're just going to set up our PopNet by hand. So always a good habit to get into, kind of, you know, another way of learning how to get DOPs to work is to actually set them up yourself instead of relying purely on the shelf tools. So we'll do that. We'll throw down a pop solver. If you remember from our previous lesson, we need one of those. We also need a pop object. Because the pop object we're going to be attaching data to, so it flows through like so. And then the data we want to bind into the pop solver is actually going to be the pop source. So we're going to throw it on a pop source. So, and wire that in over here. You hover over this, you can see that down here it gives us a little message that says pop solver sources. So just wire that guy in there. And I'm just going to, now the cool thing about having this quad view is because I've got this pop source set here and it's looking for a SOP, I can just drag my points null right in there. So you could pick it from here. You see points is available, but I like this view because you can really kind of, you can drag parameters back and forth. It makes things super handy. So the next thing I want to do is if I go back to frame 0 and click play, nothing's really happening. And that's because our source points are just points where our source is actually looking to scatter on surfaces. So I got to change this to points, or I'm going to change it to actually to all points. All points means that it'll emit from every single point once per frame. So if I go to the birth tap, you can see our impulse activation is 1. So now if I click the play button, nothing happens, and that's probably because those points are being birthed, but they're not moving anywhere because there's no forces in our scene. So let's just add a little bit of a force. I'm going to add let's just add a pop force and add some turbulence. Oops, pop force. And I'm just going to add a little bit of turbulence into the scene so that we can see things move. So if I increase this amplitude here, let's just increase this amplitude to something like 3 and click play. You can see our points are being emitted and they are being turbulented off in all different directions. Now, I just want to create my points on the first frame. I don't want it to be emitting continuously. I just want to create my points on the first frame and then simulate those points. So I'm going to just restrict that to the first frame. You could go up here, and on your impulse activation, you could key this and then move to the second frame and then turn it off. That's a perfectly fine way of doing it. And if I just turn this pop force, I'm going to turn this pop force down, temporarily insert a gravity. Or actually, no. Instead of that, I have a force up here. I'm just going to make it more uniform. I'm going to turn the amplitude down and increase this force up here to -9.8. So that should be the same as simulating gravity, and should just drop one big chunk of points down and then be done. So that's cool. Whereas before, when we didn't have these keys set, it was doing it and just continuously emitting it. Another way I like to do this, I'm just going to right click and say delete channels. So now it's just emitting continuously and those particles are falling. I'm going to just I like to put a little expression in here. So what I'll do is I'll put in a $F, which is for frame, and then say equals equals 1. So adding the two equals in there is sort of like a syntax thing for logic, but it basically says this evaluates to true when the frame equals 1. And it'll evaluate to 0 on whenever that is not true. So basically that says that just emit on frame 1 and then be done. So if I click play, you can see that it emits those particles once and they fall, and then we're good. Cool. So now I'm just going to turn down this force. I'm going to switch that the actual force vector back to 0, and then I'll bring our amplitude back in. We'll just put it back to 3, and then maybe this swirl size is looking a little bit tight. This is getting extremely random extremely quickly. So I want to kind of just loosen that up a little bit. Let's try a swirl size of something like let's do 4.25, something like that. And now if I play that back, you can see we get this swirl looks a lot curlier and just a little bit more legible for this scene. Now it's swirling this stuff off into infinity, and what I want to do is just counteract that by bringing the particles back in. So we'll use a pop attract for that. I'm going to go throw it on a pop attract. So. And if I just click play, there is an attraction force that is accelerating it towards 0.000. So what I'm going to do is just increase that force scale until I can see it coming back. I'm also going to turn on my real-time toggle here, just because when you're running Sims, it's kind of hard. If it's efficient, and it will run faster than 24 frames a second, and then you want to have kind of like a real idea of what's actually going on, and it'll be moving way too fast. So let's just increase this force scale to something like maybe 4, around 4. And there you can see that it's adding that turbulence, but it's kind of sucking things back towards the center. So we've sort of, achieved some balance here. Now you could continue to increase this and try to balance things out, which we'll continue to do as we go on through the simulation. But we've already sort of established some sense of balance already, which is great. Now the pop source, which is blue, is just sort of staying there, this guide. Don't really want to see that anymore. It's kind of distracting, so I'm just going to turn that off. Let's go back to frame 1. And you can see it going through. And you can also see that because we have ghost others objects on, we get sort of a ghost of our particles floating around there in the first place. I'm just going to say hide other objects, so that goes away. So really we can just kind of focus on what our particle sim is doing right now, just kind of flying around, looking pretty cool. And I want to visualize the scale of these particles, because ultimately I want these particles to collide with one another. So I'm going to bring in a pop sprite. Pop sprite basically works the same way as the sprite does out in SOPs. But here I see it seems to be a little bit more reliable in terms of it updating this image correctly and everything. So you can see we've already got our colors in. It's doing by default these little smoke puff sprites. I'm just going to go up here and click the piece of paper on the side. And now I'm in the HFS Houdini /pick. By default, that's cool. I'm going to just... if not, you can navigate there, but I'm just going to scroll down and select my sphere deep pick, hit accept, and then I might just have to click back to frame 0 or click play, and then you can see the spheres end up showing up and looking the way we think they should, like you would expect. Cool. So now we got all these particles swirling around. That's looking cool. So let's see. I think what else I would want to do is maybe at this point, to balance things out a little bit, I'd add a little bit of drag. So I'm going to throw down a pop drag. Just going to wire this in right here. After that, attract. Really, the order here probably doesn't matter too much in terms of it going down this line. Basically, I think that it would execute in order, but honestly, it doesn't seem to really have too much of an effect, but you know, maybe it does. At any rate, this is where I put mine, so that's cool. And then I'm gonna just let's just play that back and see how things go. You can see that because it's kind of damping the energy a lot, everything's sort of just getting sucked into the middle and sort of disappearing into, I mean, everything's just starting to overlap and stuff like that. So if there was a way I could keep these particles apart, that would be awesome, and there is. So I'm going to actually use a pop grains. So pop grains, like we discussed before, is a pretty basic PVD solver that kind of like just acts on your particles as part of the pop solver. You just kind of throw it in here, and then you get all these options to mess around with. So first thing I want to tick is it's going to assume a uniform radius that we supply to it, and I actually we have made a non-uniform radius. We've got particles of different sizes, so if I uncheck this, it's going to behave according to the sizes of our particles. So if I click playback now, you can see that these all these particles are being sucked in towards the middle, but they're not collapsing in on themselves anymore. They're sort of, you can see they're sort of holding their shape and pushing apart, pushing each other apart, which is cool. So yeah, you get this sort of like undulating kind of dance going on in here, which is nice. As you'd see, our particles kind of do this like dance, and they sort of collapse in on one another, and just kind of swirl around a little bit. And then after a while, it's, you know, I mean, it's pretty cool, but I kind of wanted to add just a little bit more to it. And I thought it would be cool if there were like these colliders that were kind of bouncing in and out and kind of pushing these around even further than just the invisible forces. So I'm going to go create some colliders for us. So let's go, what I'm going to do is I want to actually have my DOP.NET be over here. So one way I can do that is just grab any node in your DOP.NET and just drag it over to this left network view, and then boom, it just updates this side to be whatever view you had that you dragged from. Then I'll just hop up here to the object network, and I will create a collider. So I'm just going to create a geo node, and I'm going to call this our collider. And I'm going to just name the sphere 1 to be something relevant. So I'll call this source points. And let's just dive into the collider and create a new collider. I'm going to do another sphere. Boom. I'll create a polygon sphere and just increase the frequency a little bit, something like 7. Not too few, not too many polys. Should be pretty good. Cool. So I think maybe what we'll do is we'll start with just 3 colliders. So what I'm actually going to do is scatter a couple points on here, 3 to be exact. So I'm going to take the force total count number down to 3. So we got our 3 points there. I'm going to just make them a little bit bigger so it's easier for you guys to see. So let's go to point marker size up like that. All right. Nope, that wasn't it. Geometry points. There we go. I always get those two confused. So you got our 3 points here. And then I'm going to copy the points. And if I just copy the original sphere onto these points, we should get 3 spheres floating around. Cool. These will be our colliders. I just want to randomize this a little bit more. I want to randomize the scale like we did on our previous in our previous setup for our points. So I'm going to put down an attribute randomize, and I love doing the ramp version of this. So let's go. Attribute name is going to be p-scale, and you can see it's already changed the scales, or already randomized a little bit. I'm going to just do I'm just going to do another custom ramp and fit value 0 to, let's see, maybe fit value 0 to maybe 0.5, just so things don't get too crazy. And let's see if can I dial this? Yeah, something like that. So we got a couple small ones and a larger one. That's cool. Maybe I'll bring this. Yeah, I don't know. We'll have to see how it all plays out. Because the next thing that I want to do is add a little bit of noise to this in terms of its position. Now, I could animate this. I could create another particle system, but what works just good enough is another attribute random attribute noise. So attribute, let's throw that down. Attribute noise. Just put it in right after this attribute randomize. I'm just going to go in here. You can see we got our points. It's doing color by default. We're going to switch this over to position. It is adding to our position. We want to center that noise again. Let's increase the amplitude to something like 5, maybe. And then let's just play that back. And it's not doing anything because I haven't checked this animated option. So it's going to check animated and play that back. And you can see we got these points that are wiggling around. I just want to smooth that motion out. So we could do that by just going down here and dialing our roughness back to 0. So now we sort of have this like much more smooth motion, just smooth dancing of these points around, which is nice. Let's maybe increase that just a little bit. It's looking a little bit too slow. Do something like maybe 3.5. That'll be good. So we got this nice kind of dance that our points are doing, and now our spheres are also doing. And then what I want to do is I want to kind of restrict this. I want them to pulse so that they go in and out, but I want to restrict them to one plane so that we can set up our camera facing down the x-axis and then have it interact so that it isn't like kind of pushing through Z space so much. So I can actually go throw down another transform after the attribute noise that is adjusting our position. And if I just scale this down, if I scale down in X, if I'm hitting play, you see if I scale this down in X, it just sort of constrains everything. Scale this to 0. All that motion is being constrained onto the YZ plane, which is what we're after. But the motion, like I was saying, I kind of want the motion to pulse in and out. So I want it to start like in the center of this of the world, and then I kind of want it to blast out and then continuously go out and in and out and in, so that it can kind of be messing with our particles in such a way. So I'll do that by actually messing with this uniform scale. The uniform scale is going to scale the position of the points, but the clones that go on them are going to remain the same size. It's the coolness of being able to add this prior to our copies, that we can manipulate the locations that we're copying to instead of the overall scale of our objects in general. So right here, what I could do is I could throw down a sine function. I'm just going to throw sine in here, S-I-N, and then I'll do sine of at frame. So it's basically going to do a sine function based off of what frame we're on. And you can see that it will go to the middle, and then it'll grow back out, and it'll just continue doing that like so forever. I think that right now I'm already noticing that we don't have enough amplitude, so I'm just going to go up here on our position noise. I'm just going to increase that amplitude to something like 11.6. Sounds good. And you can see now it kind of grows out, and it comes back in, and then it goes out, and so on and so forth. I'm just going to give myself 1,000 frames to work with for now. So I just went down in this lower right-hand corner and changed that number to 1,000 so we can kind of see it go through more cycles. I do kind of want a slower motion to this because I want it to sort of be a hypnotic dance that's going on. And then after the fact, if we need it to go even slower, we can always time remap it. I think another thing that I want to do is actually scale the size of the spheres so they actually are able to dive inside of our geo as well. So I'm just going to go up to the sphere right here, and I'm just going to throw down a transform on the left branch that's feeding in. So we're actually taking this sphere that's created up here, and we're going to be scaling it without messing with any of this stuff. Because if we feed this scale in here, it's going to start, you can see that if I adjust this scale and have these values, if I adjust the scale, it's re-randomizing where those points are seated. We don't want that. So I'm actually going to wiggle that off, put it on this left-hand stream, and I've got this uniform scale. And I think what I'll do is actually kind of sync it up to what this one's doing down here. So, if I've got, I'm just going to hit stop, go back to frame 1. This one's doing a sine function. I'm just going to right-click, copy parameter, go back over to this transform, onto the uniform scale, right-click, paste relative references. So now our spheres should be doing that as well. And you can see that it's turning blue. That's because it's actually turning inside out, and I don't want that. So I'm going to throw it on an absolute value. I'm going to wrap this whole thing in an absolute value function just to keep it positive. So stay positive. ABS. Open parentheses, and then just go all the way to the end here and close it. So now it just stays, like white, and we don't get any of that blue color coming in anymore. And then I think the last thing I want to do is I don't want to limit it to going all the way down to fully 0. You can see it just gets microscopic and disappears. So I'm just going to limit that. And because sine function goes from 0 to 1, I can use a fit 0, 1. Basically, it's a range mapper that automatically knows that its input is in a range between 0 and 1, so we can just worry about setting the outputs and not have to worry about the inputs. So let's just limit that lower scale to something like maybe 0.3. And then, of course, we'll just let it go all the way back up to 1. So now instead of going between 1 and 0, it's going from 0.3 to 1. So when I wire this in here, when it goes in tandem with our other particles, you can see that it scales up, and then they all scale down to the middle and then bounce back out. And I think that something like this should look pretty cool when we get it to kind of do that dance with our particles over in Pops. So let's add a collider here then. And I'm going to put down a null here just to note what we've got. So collider geo. And I'm going to throw down over here a static object. So a static object like so. And it's thinking about something. I'm going to hit escape. It's probably trying to sim because we're on frame 414. It's going to go back to 0. So we've got our static object. I'm just going to drag our collider geo into the SOP path. And then I'm going to say use deforming geometry because this is inside of a geo node. This geometry is deforming technically, even though it's the positions of objects moving around. Because we're inside of a geo collider like this, like if this was moving around, if this was the thing that was moving, we wouldn't need to use deforming. But because we're inside and we're grabbing this geo, we need to use deforming. So I'm going to, we're going to grab that, and then I'll throw down a merge. So remember the collisions, left inputs affect right inputs. If you look right here, just wire this in here and this in here. We want left inputs to affect right inputs. That's good. It's a collide relationship. Awesome. Basic defaults. It's going to work. And so now, if I play this back, we should have our spheres popping out. There we go. Our spheres come out and they're pushing our particles around and creating some interesting behavior. You get these nice kind of trails going off as all these other particles are consistently trying to seek towards the origin of our scene based off that attractor that we have, which is cool. Now they've shrunk in there, and it should blast them out again. So we get these colliders popping out and dragging some of those particles with us. That's cool. So we're getting there. This is cool. This is getting fun. So if I've got a cache here. You can see I've got like you can see once you get to a certain point, it starts actually deleting your cache. So I'm just going to play that back and starting to get some really fun, playful behavior here, which is great. But one thing I discovered that makes this a little bit cooler is actually we could tell our sim to actually attract towards these spheres instead of just attracting to the origin. And I found that it creates some pretty cool behavior. So we can do that up on our pop attract. It actually has an option here. We can go into our goal, and instead of just attracting to any goal position that we would put in here, we can select to attract to points. And then we just have to give it a SOP path. Now I could just put in our collider geo, and that would kind of, attract to all these points. I think I just want to attract to the centers of each point. So I'm actually going to just branch off another null from here. We already have those centers. So I'm just going to make another null here called attractors. And I'm just going to drag that up into our SOP path like so. Now by default, those attractors over here in Pops are going to, it's going to be using, if I go back to this pop attract, it's using the average position here, which means that it's actually going to be averaging the point, the center of all three of those points combined together, which is really just not going to give us that much, that it's not going to be that much different. You can see it's kind of trying to go to the center of this triangle that's being created by all these points. I mean, it does look pretty cool, no doubt. But what you can actually do is select to have it go point per particle, and then basically it uses the particle ID and then just probably modulos through it to just add it up to match it up with one of these inputs. So now if I go back to frame 0 and click play, we got our colliders pulling these apart, and then you can see that there's sort of some of these particles are choosing to go in separate directions and chase these other spheres around until they come back together in the middle, and sort of until the particles come back to the colliders come back to 0, which is great. Just gonna let that play for a little bit and just kind of observe what's going on with it. Yeah, I really like how there's almost like this trail like coming off of these spheres. It's really fun. And it's all kind of moving around it. Now that I've got some of my cache stored away here, I'm going to just come back here, maybe just play it back in real time, just kind of see what it's doing. Yeah, it's getting really fun. One thing I want to check out is what my colliders are doing, how they're looking. Collision can be kind of tricky in Houdini sometimes. There's about 1,000,001 options in terms of how you get your collisions to work. And so there are many ways. By default, this static object is going to be doing our collisions as this ray intersect method, which seems to be working out okay in this example. But what you can do to actually make that result even cleaner is you can we could create a VDB proxy and use a volume collision. So I'm going to set that up real quick because I found it to yield more robust results. So let's go over to our collider geo here and let's see, highlight that. Yeah. And then I'll just convert this to a VDB. So I'm going to say VDB from polygons. So just throw that in there and we get a VDB. That's good. I'm going to just increase the resolution of it a little bit to something like 0.05. And if I play that back, you can see we got our surface like so. And I'll just throw down a null and call this null R. Capital space collider VDB. So we've got our collider geo, our collider VDB. So now if I go back over here, so the reason why I'm doing this, let's just turn off the pop object for right now. I just want to look at these spheres. If I go to my static object under collision and turn on my collision guide and turn off display geometry, you can see that the collider is, it's trying to figure out what is going on, and it's using this uniform divisions. It's using 30 uniform divisions, which kind of creates a weird hole here. And then as our objects get further and further apart, you can see the resolution of them is actually decreasing. So that can yield some like kind of not savory results in the end of your simulation. So we're going to explicitly define our own collision approximation by using this VDB. So let's go over here to volume sample. Instead of ray intersect, our mode, set volume sample. And now I'm going to just go down here to where it says proxy volume and just put our collider VDB in there. So now I go back to frame 0 and play this out. You can see that this is now holding a nice spherical shape for us. And it's sort of evenly spaced, this grid. It's kind of hard to see, but there is a grid there. And it is very much more, it just looks better. So again, if I delete the proxy volume out, go back and play to frame 49 on ray intersect mode, you get these kind of chunky, unpredictable kind of geo. But going back to volume sample, throwing collider VDB in that proxy volume, going back to 0, resetting the simulation, and playing it through to, you can see that this is just much cleaner collision geometry. So that's kind of my preferred way of doing collision geo. I'm going to turn the collision guide back off, turn our display geometry back on, and we'll play this down a little bit. Let's go back, and we also need our pop particles as well. Another couple things I want to do just to optimize this scene to make it run a little bit faster is I want to give some leeway to this pop grain solver. Now it's doing a whole bunch of work to push these particles apart and calculate friction and stuff like that. I actually kind of want to have a little bit squishier of internal collisions. So there's actually a internal collision weight calculation here. So what I'll do is actually turn this weight down to something like 0.01, and then I'm also going to turn off accurate friction. I'm not 100% sure what this does, but I imagine that turning accurate friction off will make things perform a little bit better. So I really kind of want these particles to like really kind of self-intersect a little bit and just have a little bit more freedom to kind of interpenetrate one another, but still be kept apart a little bit. And that's one of the cool things about being able to control this part of the solver, is that you can actually make softer collisions. Constraint iterations can play into that. I don't feel it necessary to really turn those down any further at this point, but you could do that as well. Or if your collisions are too soft, you could increase them, which is cool. So one thing I'm noticing now, if I play this back, I'm really liking the way that this is looking. I definitely think that it's possible that we could use a little bit more air resistance. Just maybe crank that up to 2. Our pop force, it was having a lot of an impact, but I think if you notice, one of the things that's happening here is I'm constantly like moving my camera around to see where the sim is actually going. So one thing I want to do that I can actually one thing that's kind of cool to set up using some capabilities of chops is to actually have this dynamically follow our object. So let's just go back up here to our object level. I'm going to throw down a camera. Actually, first I'm going to go back to frame 0. I'll get kind of, here, looking down the x-axis, and I'm just going to hold down the control key and click camera. That makes a camera out of my view. Just going to grab this manipulator in the center and pull it up a little bit. So maybe I'm, kind of centering my object like so. And then I want to create a look at object. So this is similar to creating like a target tag in Cinema 4D. It's just a slightly different process to set it up, but I'm going to throw down a null. So this null is going to be our target. And I will just, what I want to do is get this null to follow the center of our collider. So I'm going to go down here, and I've got these attractors. So really, if I just compute the centroid of these attractors and have our camera aim at that should give us some pretty cool, that should generally follow the sim pretty reliably. So let's go up here, and for our null, I can actually just use our centroid function that we've been using. So let's type in centroid here, and then I want to go out into this directory. So now we're out in the object. And then I want to jump into my collider, so I'm going to click that, and then I'm going to select my attractors like so. Then I'll just close the quote, hit a comma, and then d_x. That's just to grab the x dimension. I'm going to grab all of this and hit copy, Control C, hit tab, Control V, go back, change this guy to a Y, tab, Control V again, change this to a Z. Capital Z to be exact. So now if we kind of watch I'm going to just turn off the sim for right now. I'm going to turn off the source points and just kind of observe the collider geo moving around and how our little null is behaving along with that. So if I just play this back, you can see the null is assuming the centroid of these spheres. But it's kind of got this, like, it's got a little bit of a jerky movement to it because it's like reaching some, I don't know, it's calculating the centroid of these points, and it might run into a situation that is a little bit, just a little bit sharp. So I could actually use chops to smooth this out. So if I was to, first create this as a target, I'll just do that real quick to demonstrate. So I grab my camera, and I go up here to my constraints tab, and on the shelf, I just select look at. And it says now select look at object if any. So I could just select my null in here. I could select it from here. But when you hit enter, just make sure your mouse is back over the viewport. Just hit enter. And I don't have a lookup object, so I'm just going to hit enter again. And now if I dive into my camera, you'll see the null stays centered, but we get this kind of bouncy, erratic behavior. So I'm going to use chops to actually smooth this out. So let's just go back, hit stop. I'm going to go back here. And now in our camera, where it says constraints, I'm just going to untick this. I'm going to disable the constraints. And I'm going to create another null. And this null, so this one is going to be our centroid. And then this one is actually going to be our lag target. So I'm going to call this lag target, like so. And I'll just put that right there for right now. And then now here, what I can do is I can go up to the same constraints tag, and I can tab and select lag. So it's because I had the lag target selected. Now it's asking me to select the object to follow. So again, I'm going to select the centroid null, move my mouse back over the viewport, and hit enter. And now it has created a little graph for us here. You can see that it is doing the lag for us. So if I play this down, you can see that I've got my two nulls, and then one of them is lagging behind the other slightly. And if I let that play through, you can kind of see. So I'm actually going to dock this. I'm going to close this motion effects view and just open it up here next to my geometry spreadsheet by clicking the plus icon and going over to motion effects view. And then I'm going to it creates this motion effects network right here. So I'm just going to jump inside there. You can see that I've got my lag object right here. And now I can just kind of dial in that lag. So if I increase that lag to something like 2, you see that it gets a much smoother, it's following at much smoother rate to these objects. So maybe I'll bring that back a little bit. I'm gonna hop in so I can see from my camera what that looks like. Again, I haven't hooked this up yet, so I actually have to jump back out here, grab my camera, choose look at from the shelf up here, select my lag target now this time, then put my mouse back over the viewport, hit enter, and if I'm looking through my camera, I should be, I gotta click enable constraints. And I don't see my constraints, so let's go in here. Okay, it looks like, so the constraints that it's referring to on the camera, because we already set them up. So I click enable constraints and I dive inside. You can see there's a constraint network right here. And then there's our look at right here. It's actually looking at our null one object, which is set to the centroid. I'm just going to select, instead of the centroid, I'm going to select the lag target and hit accept. So now when I go back up to the camera, up to the object level, this should be following our lag target. But you see it stops after a little bit. And I think that by default, Motion Effects thinks that the frame range is like 10 seconds or something like that. So let me just go up to the centroid object channel. It says on this object for the centroid object, it looks like it's using start end is 10. I'm going to just use the full animation range. You can see that it actually scopes that out for us. So yeah, so if I put the display flag, and I'm going to untick it off the lag target, put the display flag on the centroid, you can see the centroid value's got these very sharp edges to it. So I could use this lag and it kind of smooths that out a little bit. I could potentially do something else, like maybe a filter, and maybe filter out high frequency noises. So let's just try that out real quick and see if it happens. So I'm just gonna turn off the lag, and I've got the pass and the centroid. So let's just turn this down a little bit. I think that I'm doing a low pass. I need to do a high pass. Let's bring that. Oh, that's not working. That's not working either. Let's see if I turn the centroid object. Oh yeah, it looks like looks like nothing's coming through. It's because the scope needs to be TXYZ. So I'm just going to copy TXYZ for translate and paste that in here. Yeah, it looks like that isn't happening. I'm going to switch this back to low pass and bring this high cutoff way down. Yeah, and it looks like it's starting to do the thing, but I got to get it's really finely adjusted. So if I go back to, let's do a high cutoff of 0.14. there you can see it starting to smooth out that geo. Now it might even actually follow the geometry a little bit better. You can see the lag kind of drifts behind it a little bit, but this high pass filter actually filters out that high frequency noise and kind of sticks with the original waveform a little bit better. So maybe let's just get out of here. I'm going to just throw down this lag at the bottom here. You can see, I'll go back to 0. Yeah, you can kind of see that the camera now has a much smoother motion, and it's sort of adhering to the center of our, let's go back to camera 1. You can see that it's just sort of following a little bit nicer. All right, so I think that at this point, I want to cache this setup. So the way it usually works, we've got our sources, colliders. They all go into our .NET. Our .NET processes them. So we get our stuff from SOPs, we send it into DOPS, and then we import it back out of DOPS and put it back into SOPs. So let's create another geo node to bring our geo out of DOPS so we can do a little bit of post-processing on it. So I'm going to call this geo node export particles. And we'll just jump in there. And to get our geometry from a DOP network, I'm going to put down a DOP import node. And then I'm just going to, in the right view here, just hop over to the DOPNet. And, well, actually, I'm going to go up here and then select the DOPNet. And I'm just going to throw that up into our DOP network field because it's going to need to know what DOPNet it's looking into. And then for an object mask, right now it's set to grab everything. So what it'll grab when it grabs everything is all these objects. So we got our static or pop object and our static object here. So it'll grab these guys and bring them in by default, but it doesn't say, the import style is not set correctly. It's saying transform import geometry. We actually want to fetch geometry from DOP network. So I click that and you can see that it brings in looks like it brings in our points and they're all scaled funny. Not quite sure what's up with that. But what I want to do is actually not have it grab all the geometry. I don't want to bring in the colliders just yet. I want to actually just bring in the particles themselves. So I'm going to actually, where it says object mask here, because it's a star, it's going to grab all the objects, but I can actually just specify the pop object itself. So I'm just going to grab this, the name of this, and instead of the star, I'm going to type, I'm just going to paste that in there. So it's only grabbing the pop objects. So now in this view, you can see that we've imported our particles, and whatever was going on with those sprites has now been fixed. I'm not sure what that was. Now we've got our particles. It's bringing them in, and there's no collider geo. We can actually just generate our collider geo back in SOPs where we created it in the first place and export it there if we want it to go into our other, if we want to bring it into another app. So, I mean, it's still behaving correctly. It's just the particles by themselves. Cool. So I think that at this point, if I middle mouse click, you can see there's just a bunch of attributes right here. I'm not quite sure which attributes I really want to keep or which ones I want to get rid of at this point. And I think that they're all in all pretty low. They're pretty light. So I'm just going to file cache this out as it is. So let's just throw it on a file cache. And it by default is going to hip/geo/hipname.of.bgo.sc. I find that that's an okay location. Basically, it's going to create a file next to my geometry, or next to my hip file. It's going to create a geometry folder and then call it this. But if I want to export more than one geometry, then basically I've got a directory full of OBJ sequences or whatever, BGO sequences. They're all next to each other. So I like to kind of tidy this up a little bit. What I'm going to do is I'll actually go up to my edit parameter interface. I'm going to go over here and add a string. And I'm going to just throw this string in right above my geometry file right here. And this string I'm going to call version. This is a lot like the token system. It's a little setup that I like to do, and I create a preset and it works pretty well for me. So I'm going to click apply and accept here. And now I've got this version. I can put anything I want in here. So what if I actually want to create the my directory? I want to put my caches into a cache directory instead of a geo directory. And then I want to cache out based off of the name of this node. So let's give the node a descriptive name such as pop cache, since we're caching out our pop network. And I'm going to make the next directory down $OS. That means that it's going to go and create a directory called cache next to our hip file. And then in there, it's going to have a pop cache folder. And then we can store all of our pop cache versions and iterations inside that folder. Because I like to keep a paper trail that leads back to the original project as the version name, I would, at this point, put down another $hip name. So it'll create a folder based off of the name of our current project, which is fine. And then it will name these the rest of the geo accordingly, using also the operator and hip name, and then $F for the file name, and .bgo.sc. But so if there ever comes a point now where I need to hard code in hip name, because suppose I've saved a new version of this file, but hip name is actually the old version, I got to go in here and hard code in the name of this file 2 times, which I don't want to do. So I'm actually going to extract hip name out to the version right here. So we're going to put hip name up here, and then down here we can actually copy this parameter and paste relative references here. So I'm just going to say paste relative references. You can see that it puts these backticks in, which means basically look up the version here and convert it to a string. And we're going to also put that right here as well. So I'm going to select hip name, and then basically I just need to delete it like so, and right click in there and say paste relative references again. And so now if you're worried about what it's going to look like, if I just middle mouse click on this, you can see it's going to my E directory, lesson file, cache. So next to my hip file, it's going to create a cache folder. Then it's going to create a pop cache folder. So if I have multiple different caches, they're each going to get their own folder full of versions, folders of versions, and then inside there will be these gigantic sequences. It'll be really easy to look at and really easy to deal with. And for the most part, it's on Rails, and we won't ever have to deal with it again. So at this point, what I would do is save a preset. And I go down here and say save preset, like so. And you can see I've got my own versioning preset right here. So if I actually recall that, you can see that it brings this all up. Oh, it looks like I named my version just a little bit shorter, so it was a little bit more legible. But it says ver here instead of version, because if I hover over here, that parameter that I edited was called ver. So just a quick tip I think that would buried inside of a gigantic tutorial. Hopefully that hopefully you found this and it helps you in the future. So I'm going to cache this out now. I'm going to cache the whole 1,000 frames. I don't really see a reason why not to. It doesn't take up too much space, and it doesn't take too much time. And so this way we'll get a whole bunch of frames. We can choose which section we actually like. So stay tuned, and I'll get back to you when this is done caching. All right, so the simulation is done cached. The simulation is done caching, and now we can see if I hit the play button, you can see it playing back here. One thing about playing back, you can see it's kind of running a little bit slow. And if you look at our geometry spreadsheet, it's just working overtime here, loading in all these attributes that it's reading off of disk and updating this gigantic spreadsheet full of 100,000 entries times however many attributes. So I'm just going to actually just collapse this view down so it doesn't have to think about that so much. I'm going to hop back into the camera view that we set up before, the one that kind of tracks it around and follows it and stuff. And what I want to do is maybe, I'm looking at this, I just kind of want to get, maybe want to get in a little bit tighter, just to get like, just some more kind of a macro vibe going on. I see this simulation kind of collapsing down into some very small shapes in the center of the frame. If I hit the D key, I can kind of switch my background to the lighter mode so I can get a better view of my cropping region for the field of view. And yeah, I mean, this works. I just want to kind of see what other options I've got. So maybe what I'll do is I'll actually grab my camera here. I'll go to the view, and at this point, maybe I'll just set this to 1080. If I was going to render out of Redshift In Houdini, I'd want to set this, but let's just maybe dial the focal length up a little bit. Maybe something like 80. Let's just see what that looks like to play it back. Now, I can still see my nulls here. I just want to do a little flip book, which is basically what a hardware preview is called in Houdini. I'm going to just hide my two nulls so I'm not sort of distracted by those. And let's just fire off a flip book. So down here, I'm going to hold down on this flipbook and check this flipbook with new settings. That's good. Then I'll just go over here to the size tab and make sure it's got crop out view mask overlay. That's cool. And I'll just do this at 1080 as well. So you can select the resolution from there like so. And then I'll click start and it'll load all of these frames off disk. And it's giving me a warning saying that I have 1 day left to renew my Houdini Indie license. So I guess I'm going to have to do that. Take my money, you know, like, yeah, it's looking cool. It'll be really great to see this thing play back in real time. That way we can really kind of know what we've gotten ourselves into. And though it's really kind of hard to tell at this point without the grid in the shot, the camera, I believe, is tracking with the simulation. It is following it around, following that null, that lag null that we created. Everything is seeming to remain like relatively decently composed in the middle, and obviously this doesn't have to be our final camera move. I'm just sort of doing this for demonstration purposes. I think that in the end what I would ultimately do is just select a certain section of this to be like the shot that I want. I don't really necessarily feel like rendering out 1,000 frames of this just to get this look. Might find like might make a highlight reel out of what we get from a sim like this, especially if it's lightweight and easy to calculate.